Hello everyone, welcome to my channel. Now in this video I am going to give a brief introduction on the topic refraction from the chapter ray optics. Now as we know that if we have two different medium, suppose this is medium 1 and this is medium 2 and this line represents the interface of these two medium. If a ray of light is incident obliquely, this is the normal at the point of incidence, then this ray of light may bend towards the normal or it may bend away from the normal depending upon the nature of the two medium. Now this bending of light, when a ray travels from one medium to another medium in an oblique direction, the ray must travel in oblique direction, then this bending of light is known as refraction. So if you are asked to write the definition of refraction, you can write it as the direction of propagation of an obliquely incident ray of light that enters the other medium changes at the interface of two media. This phenomena is called refraction. The ray must be incident obliquely at the interface and there is a change in the direction of propagation. So the ray may bend towards the normal or it may bend away from the normal. So in that case we say that there is a phenomena of refraction. Now this phenomena was studied by Snell and he proposed the two laws. So then we have the Snell's law of refraction. The first law says that the incident ray is the incident ray, the refracted ray and the normal, they are coplanar. Normal is at the point of incident. So the first law says that the incident ray, the refracted ray and the normal to the interface at the point of incidence all lie in the same plane. Then we have the second law. Then we have the ratio of sine of angle of incidence to sine of angle of refraction is a constant. Now suppose this is the interface of medium 1 and medium 2. This is the incident ray, this is the normal at the point of incidence and this is the refracted ray. Okay, so this is angle of incidence, this is angle of refraction. So ratio of sine of angle of incidence to sine of angle of refraction is a constant. So sine I by sine R. This ratio is a constant and it is equal to refractive index of medium 2 with respect to medium 1. Okay, medium 2 with respect to medium 1. Okay, there is another way of writing this expression. Like suppose mu1 is the refractive index of first medium and mu2 is the refractive index of second medium. So you can write like this: mu1 refractive index of first medium multiplied by sine of angle formed in that medium. So here mu1 medium of refractive index mu1 angle formed is I, so mu1 into sine I is equal to this side medium is refractive index mu2, angle formed is R, so mu2 into sine R. So we have sine I by sine R is equal to mu2 by mu1. So that is equal to mu2 1, that is refractive index of medium 2 with respect to medium 1. This notation is for refractive index of medium 2 with respect to 1 Okay, so this is Snell's law. Now this term refractive index in terms of velocity of light, it is expressed as mu is equal to velocity of light in free space to velocity of light in the medium. Okay, now that means refractive index is related to velocity of light. Refractive index is also related to wavelength of light lambda by Cauchy's law. Cauchy's law, it says that refractive index is inversely proportional to lambda. So from this we can make a few conclusions. Like first is, if you see mu2 by mu1 is equal to sine I by sine r. Okay, so that gives like two possibilities. If mu2 is greater than mu1, if mu2 is greater than mu1, that means I is greater than r, I greater than r, I greater than r. So that means if the ray is traveling from rarer medium to denser medium, the ray will bend towards the normal. This angle is more, this angle will be less. Okay, so if the ray is traveling from rarer medium to denser medium, then the refracted ray will bend towards the normal. Now, converse of this, if mu2 is less than mu1, okay, if mu2 is less than mu1, in that case I will be less than r, I less than r. So that means mu2 less than mu1, that means the ray is traveling from denser medium to rarer medium. The refracted ray will bend away from normal. Okay, now from this mu is equal to c by v, what do we learn? See, mu2 by mu1, mu2 will be c by v1, v2 divided by c by v1. So that gives v1 by v2. So if mu2 is greater than mu1, that gives v1 greater than v2. So that means if the ray of light is traveling from rarer medium to denser medium, its velocity will decrease. Conversely, if mu2 is less than mu1, mu2 is less than v1, in that case v1 will be less than v2. That means if a ray of light is traveling from denser medium to rarer medium, its velocity will increase. Okay. Similarly, since mu is inversely proportional to lambda also, mu is inversely proportional to v, for that we have mu2 by v1 equal to v1 by v2. Since mu is inversely proportional to lambda, I can also write mu2 by mu1 is equal to lambda 1 by lambda 2. So similar to the velocity, as ray of light travels from rarer medium to denser medium, velocity decreases, its wavelength also decreases. Okay, similar result can be concluded with regard to wavelength also. Now from this, what do we see? See, if f is the frequency of light, frequency is v by lambda. Okay, now as we have seen, if the ray of light is traveling from rarer medium to denser medium, its velocity is decreasing, its wavelength is also decreasing. So wavelength and velocity and wavelength both are decreasing. So this means this frequency of light will remain constant. Frequency will remain constant during refraction. So in refraction, there is change in direction, there is a change in velocity, there is change in wavelength, but frequency of light will remain constant. So these are few concepts related to refraction and Snell's law. I hope this is beneficial to the students preparing for both board examination as well as the forthcoming JEE and NEET examination. So good luck and my best wishes.